So I'm going to use the golden rectangle that I created in the last video to touch on something else. So we have our golden ratio right here, but there's another way to think about it, to represent it, and it's this expression right here, 1 plus the square root of 5 divided by 2. And I just want to show you how one would arrive at this. Okay, so here we go. We're going to use the Pythagorean theorem, Pythagorean relationship for this. So I'm going to draw a line segment here to give us the right angle triangle that we need. Now, we need to make some assumptions here. So let's say that all the AD and EF and BC are equal, obviously, and they have a length of 1. So all of these line segments that connect the longer edges of the rectangle are 1 unit long. If that's the case, we know from our work up here that line segments AB and DC are equal to this value right here, the golden ratio. But how does this fit in? Well, here we go. So when I created this rectangle, I created this point here by constructing a midpoint. So that split DF, line segment DF, in half. Because of that, we know that this part of DF, this side, is one half of a unit. If the full side of the square is 1, then this section is going to be 1/2. Now, according to the Pythagorean theorem, we can use these measurements to determine the length of the hypotenuse here. So 1 full unit, and if we make the square times another full unit, gives us 1 square unit. Half a unit, and making the square times half a unit would give us 1/4 of a square unit. So we've got the square that would appear here on EF being 1 whole unit, the square here that would appear on, I'll just give a label here, that would appear on FG is 1/4. So the square that would appear on the hypotenuse here would be a combination of that. 1 whole plus 1/4 is 1 1/4, or 5/4. The length of the hypotenuse then would be the square root of that, and so the length of the hypotenuse is the square root of 5/4. Okay, and that's important for us to know. All right, so let's go further here. So I'm going to get my circle tool, and I'm going to create a circle that goes, no, not there, sorry, that was a mistake. A circle that goes here. That's what I wanted. Okay, so G is the center of the circle, and GE is the radius. GE is also the hypotenuse with a length of 5/4. Sorry, the square root of 5/4. That means that GC also has a length of square root of 5/4. So let's put that in there. So I'm going to write that down here. So that's GC. Now this half still corresponds to GF, but right now I'm going to put these two segments together because they are a radius and they do have a combined length of the square root of 5/4. However, DG is still a half of a unit, half of this 1 unit that's here and here. So the line DC and also AB is a combination of 1/2 a unit plus the square root of 5/4 of a unit. How does that equal this? Well, let's take a look. We can reduce 5/4 by considering it as, well, square root of 5/4. We can rewrite that by saying the square root of 5 divided by the square root of 4. Same thing. But when we do it this way, we can take the square root of 4. We're going to leave the numerator alone, but we're going to simplify the denominator. So what that's going to give us is square root of 5 divided by 2. Now, I need to add these two sections together to get the whole length. So 1 divided by 2 plus the square root of 5 divided by 2 will give us this right here. So this is a statement of the length of the long side of the golden rectangle. Let's just check to make sure that this expression equals this. So let's grab the calculator and let's work it out. So 1 plus the square root of 5, and then we're going to divide all that by 2, and there it is. Let's bring it up here for comparison. There's the golden ratio.